at solving triangles, we are trying to find a distance or a side. AD is the length of a side. Now the whole story is about a monument standing somewhere on a hill, and this is a road leading up to that monument, a straight road, so a straight line. They start off saying that the person starts off here at point B, and at B, the road makes an angle of elevation. No, the road makes an angle with the horizontal. So there's a horizontal line, and it makes an angle of X. So the size from there to there is X degrees. Also, at point B, looking at the top of the monument, there's an angle of elevation. Angle of elevation from horizontal to where you're looking to, that angle is an angle of elevation there, the Y. They could have also said, looking at the bottom of the monument, there's an angle of elevation. Or they could have said the road makes a degree with the horizontal line, any which way. Also then they say, the guy gets in his car, whatever the story may be, drives P meters or kilometers closer to the monument, and there, at a point again, he gets out of his car, whatever he does, makes a picnic, and then he's looking at also again at the top of the monument. But now, horizontal line, there's an angle of elevation of Z to the top of the monument. They are wanting to find AD, which is the height of the monument, in terms of all the stuff. X, Y, Z, and P. Now remember, X and Y and Z are angles, where P is a length of a side. So P is actually given. So that length of AD is going to be something in terms of all of that. Major thing is, firstly, when you start off, you need at least one side. Do I have one side? Yes, at least I've got the P. So I'm forced, before I look at anything else, I have to work with this triangle. Triangle BCA. In that triangle is the only side that I have. I have to start with it. But before anything else, you get all of the angles. That's the golden rule. Get all of the angles. So we start off here. We start off anywhere you like. But if you start off here, and this PC here is X, it's not even in a triangle. Do you see it? You could make a big triangle. You could do some other stuff as well, but don't draw a lot of extra things into your sketch. But if this is Y and the whole thing, the whole angle is Y, the smaller angle is X, this will make this Y minus X. Is it okay to write X minus Y? No. It's not the same thing. The big one minus the small one is Y minus X. Right? Anything else? We've got the Z there as well. So could we not say that, because of this horizontal line, that this little PC here can be 180 minus Z, do you agree? But that's not the whole angle, and please remember I have to work in a triangle. Now I am going to be working in BCA, or ABC, whatever you'd like to call that. So I need this little PC here as well. What other technique could I have used to get to this little PC here? Because remember they didn't put it there, but these are all parallel horizontal lines. All horizontal lines, horizons, is going to be parallel. Making this X alternate with C, 1. So that little piece there is alternate. Do you agree? That also means that this is a vertically opposite angle, so that that little piece there will be X. Making this little piece here Z minus X. Not level 1? Definitely not. Level 2? Also not. 3, more likely towards the 4 level. Okay, so this would be Z minus X again, not X minus Z. So the big Z minus the small little x, but you have to realize where it comes from. Do you write any of those reasons? Saying it's alternate, saying that it's vertically opposite. You're just getting the mark for getting to the actual angles, for knowing that that is Z minus X. Alright? What else? Do I actually know this angle here for the moment? If I wanted to go get it, it's actually a little bit of a waste of my time, but let's do it. I'm not going to use it, but like Ma'am says, get everything that if you need it, you can use it. You're not going to use it in the sun, but if you needed it. How large then is this whole angle? Do you agree? Now, Ma'am taught you inside of your big, huge sum, there's going to be sin of the angle, cos of the angle, because those are the rules. And if there's sin of an angle with an 80 minus, that should bring towards reduction formulas. Poof, right? So if that's going to happen, you would actually like it to be 180 minus. Then what would 180 minus be? Z minus x. Because that will become minus x and plus x like you know it should be. Now you're not going to use it, but if you needed it, that's the way you would have had to write it.
Yes,
so that one would be 180 minus and in brackets. So that if there's a sin in front of it, you can go poof, and it'll just be z minus x. That's the reason why we do it. Wasn't necessary here if you need it in another one. What else do I need? So here and here, right?
Yes,
A2 in this triangle, A3 in this triangle, and am I going to use all of them? Most probably not, especially in such a difficult one. I feel like I'm working very hard to get towards it. Okay, let's get to, which other one do you want to go? A2, how will you get A2? A2 is alternate with what? A2 itself isn't, but I'm hearing what you're saying. You're going to do alternate angles with which one?
C3 and 4.
C3 and 4, the whole of C3 and 4 is there. Making it alternate with?
Whole A1.
The whole of A1 and 2 together. Do you see it?
Yes, ma'am.
Do you see the alternate one? So yes, it is the whole thing is there. Do you agree?
Yes,
But what about A1? It's alternate with x. Do you see it? So if x is alternate, I'm lying, it's y, I'm sorry. It's x if it's this one was alternate. But if it's that line, it's got to be the y. Do you see it now? Y. So this piece here would have been y. How does that help me? I need to find this angle, and this angle would then be, and not the other way around. Are you with me? Don't let your brain explode. Okay. So we've got all the angles in triangle ABC, and we're not done. We still need to get to that side. What do we have in this triangle then? What can we do? Can you find A3? Yes, because this whole angle here is 90 degrees. How come?
Because
the monument, horizontal, has to be perpendicular to each other. So if that's 90, and this is Z, then this should be 90 minus Z. That's definitely not the only path to walk towards that answer. Then over here, at D, what have we got? First of all, that's 90 degrees, but it's only a little bit of the D, not all of it. All of it's not 90. Only that little piece there with the horizontal lines put in there. But what about this little piece here then? Alternate with x. Do you see it? With C4, do you see the Z? That will be small little x, alternate angles. Do you see it? So the whole of this angle is what? 90 plus x. And the whole of this angle, I just want to write it a little bit together so that I can see the three angles separately from each other. That took us like 10 minutes to sort it out. It shouldn't take that long, right? So, depending on how you did it, you could have first done the alternate angles, worked with something else, worked with some of the angles of a triangle, but you'll get to the same answers. Alright, let's get to the sum, because that was the worst of it. And I'm not going to use all of it. No, not necessarily. We're going to have to start in which triangle? Why would you start there? The thing you're looking for isn't even in there. The only side that you have is P, which is in that triangle. So you don't have a choice. You have to start there. And then do what? Something to get you to where you want to be, namely the connecting side. So I'm going to try and find A, C. in that triangle. And hopefully, it's not going to be the cos rule with this lot of stuff going on here, but if it is, then it is. Can I use the sin rule? Are there pairs? The one I'm looking for has got an angle. The one that I have has got an angle, meaning this terrible one that I worked out there was unnecessary. But it's okay, now you know how to work it out if you need it. So I'm going to go put AC, and remember I'm still first saying the sin rule. I'm finding AC over sin of y minus x. Guys, are you with me? AC over the sin of its opposite angle. The side that I have is P over the sin of Z minus Y. Now guys, when you are given marks for this, it'll be for the sin rule. For angles as well, because you did a lot of hard work to get to those angles. So it won't just be one for working with the sin rule, like in the easier stuff. Okay? And then to find AC, next step, I'm just going to put them all together, right? So that is going to come stand here at the top, sin y minus x, sin z minus y. And just if the madness strikes you, please don't do things like say sin z minus sin y. You cannot time in sin. It's an entity, the sin ratio of an angle. You cannot time it in, that's it. Can't do anything to it. Now I'm going to have to go to triangle ACD to find AD, the actual question. Hopefully it's the sin rule again, and it is. Because I do have sides now. Which side? I've got this one, and I'm not going to attempt to write it there. I'm just going to say I've got it. There it is. So once I have it, I have no choice. I have to work with this pair, with the 90 plus that I do have. The side that you're looking for is AD, which is going to be on top of this angle that you found out was Z minus X. So we're not going to use the 90 minus Z. But we've got it if we needed it. Alright, so the sin rule again, and I'm not going to write it down because I've already written it down. If I've done it once, you don't have to write it again. The side that you're looking for is AD over, yes, AD over sin Z minus X. And the side that you have is AC. You can immediately put it in there. I just like to write it first and then substitute with this terrible thing. So it's AC over the partner. What's coming? A proof buff. There's a reduction formula of co-functions. Okay? So it could have been somewhere with 180 minus, it would have been a proof sum. It could be something with 90 minus or 90 plus, then it would be a proof buff, a co-function. Are you with me? Reduction formulas popping up here inside of solving triangles. Okay, in the next step, I'm going to substitute that AC with P sin bracket over bracket. Are you with me? But instead of saying divide by, I can immediately make it times by to save myself some space, but I need you to see what's going on here. So this is actually two things on top of each other, on top of sin. How would I change on top of sin? It's 1 over. Okay, now guys, I would have immediately had done the proof buff, the reduction formula already there, but let's keep it there for the minute. And then on this side we still have AD over Z minus X, right? So that now I can see what happens here. This is going to become negative cos X. Because remember how the co-functions work? It goes poof, gone is the 90 plus. But puff, the sin becomes a cos. But that's not it. You're in the second quadrant. 90 plus is second quadrant. And there, the original one was sin. So now cos will still be positive. Okay, hear what I'm saying? It goes poof, and it goes past. But when you want to go and see where you were with sin in the second quadrant. And sin in the second quadrant is positive. Are you with me here? Okay, get right. And then the rest of it. Can I not put all of them together already? You could. Okay, we're going to do it step by step here. So we're going to have AB is equal to P sin y minus x over enormous sum. And then that became that. And what can I do to that? Take it somewhere to the top. Remember, it's fractions, fractions, fractions. You can split them up, you can put them all together. So if that one at the bottom has to be somewhere at the top, you can have fun. Where do you want to put it? Can I put it here? And say sin z minus x. Follow what I'm saying? And then I can actually leave it that way, but it just feels like it's not finished. Normally when we've got fractions, we make one big fraction as an answer. How can I do that? Done. Are you with me? Now, most of the time, these guys tell me, prove that AD is equal to. And then it might have been this one first and this one second. Or at the bottom, the same thing. And that doesn't matter. Just try and put it the way they've got it. But unfortunately for you now, you didn't have a clue if you were right or wrong. You just had your answer and that's it. Let's just make it a little bit nicer. So that it's all together. But I actually didn't do anything by taking those two fractions and putting them all together. Alright, and that's the end of solving of triangles. Practice needed?
Yes.
For sure.